Mobile backend design involves creating application programming interfaces, or APIs, and backends that are specifically optimized for mobile applications. It's about building the server-side infrastructure that powers mobile apps, focusing on performance, efficiency, and scalability to meet the unique demands of mobile devices and networks. Mobile backend development comes with its own set of challenges. One significant challenge is the limited resources available on mobile devices, such as battery life, bandwidth, and processing power. These constraints require developers to optimize backend services to minimize resource consumption. Another challenge is the network variability that mobile apps encounter. Dealing with intermittent connectivity and varying network speeds is crucial for providing a seamless user experience. Representational state transfer, or RESTful API design, follows several key principles. First, use resource-based uniform resource locators, or URLs, to identify and manipulate resources. Second, leverage hypertext transfer protocol, or HTTP methods such as GET, POST, PUT, and DELETE to perform actions on these resources. Ensure that operations are stateless, meaning each request from the client to the server must contain all the information needed to understand the request. Use JavaScript Object Notation, or JSON, for responses, which is a lightweight data interchange format that's easy for both humans and machines to read and write. Here are some mobile API endpoints examples. GET requests can be sent to the API/users/123 URL. POST requests can be sent to API/users URL. PUT requests can be sent to API/users/123 URL, and DELETE requests can be sent to API/users/123. For nested resources, GET requests can be sent to the API/users/123/post URL, and POST requests can be sent to API/users/123/post URL. To optimize data transfer for mobile applications, several strategies can be employed. Response compression reduces the size of data transmitted over the network, saving bandwidth and improving loading times. Using minimal payloads involves sending only the necessary data, avoiding unnecessary bloat. Field selection allows clients to request specific fields, reducing the amount of data transferred. Implementing pagination divides large datasets into smaller chunks, improving performance and user experience. Here is an example of optimized response. The JSON object has the keys, users, and pagination. The user array has ID, name, and avatar keys. The pagination object has page and total keys. Authentication and security are paramount in mobile backend design. JSON Web Tokens, or JWT, tokens provide a stateless authentication mechanism, enabling secure transmission of information between parties as a JSON object. Short expiration times for tokens enhance security by limiting the window of opportunity for misuse. Implementing a refresh token strategy allows users to maintain authenticated sessions without repeatedly entering credentials. To ensure best practices are followed, use Hypertext Transfer Protocol Secure, or HTTPS, everywhere to encrypt data transmitted between the client and server. Implement rate limiting to prevent abuse and denial of service attacks. Validate all input data to prevent injection attacks and ensure data integrity. Caching is an essential technique for improving performance and reducing latency in mobile applications. Client-side caching leverages device storage and memory to store frequently accessed data locally, reducing the need for network requests. Content Delivery Network, or CDN, caching involves caching content on edge servers geographically closer to users, improving response times. Server cache such as Redis and in-memory caching stores data in memory for faster retrieval. As an example, cache headers like cache control with a max age of 3600, an entity tag or E-tag can be used. Here is a Python Redis example. The code imports Redis module. Then the ctext method on the cache object is called with keys user 1233600 and data. The get method is called on the cache object with the key user 123. Real-time communication enables mobile apps to provide instant updates and interactive experiences. WebSockets provide bidirectional communication channels, allowing for low-latency messaging and persistent connections between the client and server. Push notifications via Firebase Cloud Messaging or Apple Push Notification Service Integration, or FCM or APNs, enable background updates and enhance user engagement. Database design plays a critical role in the performance and scalability of mobile backends. Optimize read patterns to ensure efficient data retrieval for common use cases. Employ efficient indexing to speed up query performance. Consider denormalization to improve read speeds, even at the cost of some data redundancy. Implement offline-first synchronization to enable seamless data access, even when the device is offline. Here is an example of user profile table creation. Create table statement is used to create a user profiles table. The field's ID with primary key, username with varchar data type, avatar URL with text data type, last active with timestamp data type, and settings JSON with JSON data type are the table columns. An optimized index can be created using create index statement, which creates index named IDX last active on user profiles table with last active field. Monitoring key performance indicators or KPIs is crucial for identifying and addressing performance bottlenecks in mobile backends. Monitor response time to ensure that APIs are responding quickly to requests. Track throughput, measured in requests per second or RPS, to assess the system's capacity. Monitor error rates to identify and resolve issues promptly. Analyze database query times to optimize database performance. Set up alerts for high latency, server error spikes, database bottlenecks, and memory usage to proactively address potential problems. In summary, to design effective mobile backends, it's essential to optimize for mobile constraints such as limited battery life and bandwidth. Implement robust security measures to protect user data and prevent unauthorized access. Minimize payload sizes to reduce data transfer costs and improve loading times. And continuously monitor performance metrics to identify and address performance bottlenecks. By following these best practices, one can build scalable, efficient backends that deliver exceptional mobile experiences. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.